for factoring two special cases. One of them is called perfect square trinomials. So we're going to go through that one first, go through some examples of it first. Then we're going to go to the other special case. The purpose of knowing these shortcuts is it's going to make you have to work less. But then so not tomorrow, but the next day, we're learning how to solve quadratics another way. So far we learned how to solve quadratics by factoring, by quadratic formula, by just taking the square root, and then we're going to be starting something called completing the square. It's another way to solve quadratics. Knowing about perfect square trinomials is necessary to complete the square. So that's why we're going through this part. If you ever see a shorthand of PST, that means perfect square trinomial. It's one of our special cases for factoring what it is. What does trinomial mean? Y'all remember? It has three terms. So this is what we're starting with, x squared plus 12x plus 36. When you go to factor it, this would be considered an easy factoring problem. So if we went to factor it, x squared, you have 36. So what numbers multiply to give you 36, but then add up to 12? 6 and 6. So when you factor that, what do you notice happens?
It's just, they're both the same.
It's both the exact same thing. That's what a perfect square trinomial is. When you factor it and it's the same thing, so you can write it as the parentheses times itself or the parentheses squared. The shortcut is, look at the first term. Is that first term a perfect square? What's the square root of it? Look at the last term. Is that a perfect square? What's the square root of it? And now the part that you have to be careful with. Yes, the first and last terms have to both be perfect squares, but the middle number also has to be a very specific number. It comes from those something twice. That something is multiply these two terms together. What's x times 6? And then double that. Because if we were factoring, it'd be in both those boxes. So what's 6x times 2? Is that 12x? Then you can go to that shortcut. It's just the parentheses is x plus 6 squared. So this has a lot of writing. Let's go to just an example of it. So if you look at this first one, first term, is that a perfect square? What's the square root of it? Last term, is that a perfect square? What's the square root of it? What's that? Well, if you multiply these two terms together and double it, so multiplying them together, that's 7g, and then you double that, what does that give you? 14g. Is that giving you what you have in here? I mean, pretty close. What do you notice about that middle term? It's negative, which just means it's a minus sign. So your parentheses would be x or g minus 7 and g minus 7, or g minus 7 squared. Okay. Example C, that x is supposed to be a y. Fix that real quick. But the purpose of why this is helpful, if I asked you to factor this like normal, like if I said go through and just factor this, you would go through and make your area model. We've got 4y squared and we've got 81. This is not the easy factor problem. This would be the one where you have to multiply 4 times 81, which is 324. So then you're finding factors of 324 that add up to 36. You'd be sitting at your calculator for like ever and ever, not forever, but like a long time. When instead, if you can notice it, is that first term a perfect square? What's the square root of it? 2y is the last term perfect square. 9. If you multiply those together and double it, does it give you the middle term? Yes. Then that means this is considered a perfect square trinomial. Whatever that first sign is that you see, that's the sign of the Wait,
what do you mean by? Because if you double the 9, it's 18.
No, that's squaring it. Doubling it is multiplying by 2. Okay, so go to that page. Let's go through, before we move to the other term, we're going to go through a few more examples of it. So let's look at number 2. Problem number 2. first term, last term. Are both the first and the last terms perfect squares? What's the square root of each of those? X and 1. And then when you multiply those together and double it, does it give you that middle term?
Yeah.
As long as there's a minus sign. Yep, sure does. Perfect square trinomial. So something you're going to see, if you ever see PST, that means perfect square trinomial, just means one of our special cases. So if you ever see it on like notes or what like key or something, if you see the word or letters PST together, that's perfect square trinomial. Again, why we have this faster way of doing it, it helps for problems like number 6. On number 6, that's not a fast factoring problem. The first step would be multiplying 25 times 9. I don't want to multiply 25 times 9 and find the numbers that multiply to give you that, then add it to negative 30. Instead, I want to try a different option. What's the square root of 25x squared? 5x. And what's the square root of 9? If you multiply those two terms together, that's 15, and then double it, does that give you this middle term? Yes, as long as there's a minus sign in between. Therefore, it is a perfect square trinomial. You don't need any work for factoring. Okay, let's take a look at number 5. Problem number 5. First term, is that perfect square? Square root is x. Last term, is that a perfect square? What's the square root of it? Multiply those together and then double it. It doesn't match, so it's not a perfect square trinomial, which means you could still potentially factor it, right? Like, this is just a shortcut for factoring. Sometimes you still have to go through and factor it. Well, it's an easy factor because there's nothing in front of your x squared, it's a 1. So just look at 100. What numbers multiply to give you 100, but add up to negative 21?
Negative 25, 4.
Okay, but that would have to be a negative 25 and a positive 4, right? Do those multiply to give you a positive 100? That multiplies to be negative 100, right? A negative 25 and a positive 4. So are there any numbers that multiply to give you a positive 100 but negative 21? Well, that would be if we're solving it. In this case, since the directions are saying factor it, we were just okay. That's our first thing. Special case. Go back to the front. Second special case is something called a difference of squares. Difference of two squares. This is an example of a difference of two squares. What do you notice about that expression? Yeah, it's missing one of the terms. So if it's missing the x term, then it means it has the possibility to be a perfect or a difference of two squares. How to check to see if it works. First thing, always, always, always check. What does the word difference mean? This means subtraction. There has to be a subtraction sign in the middle. No matter what. No matter what. Reason being, if we go to factor this, so what we were doing before today, we were factoring this x squared negative 100. If there's no x term, what does that mean about the two other boxes? They add up to 0, because maybe look something. Well, what multiplies to you negative 100 but adds it to 0? 10 and negative 10. So when you go to factor it, x plus 10 and x minus 10. That's the shortcut every time. Because what do you notice about the two parentheses that we just got? They're the same, but opposite. One's with the plus, one's with the minus. That's what the difference of squares trick is for this problem. If you have two terms, first thing I always check, Is there a minus sign in between? So if you look at this first example, example E, is there a minus sign in between? All right, that is always step one, because if there's not a minus sign, those two parts can't eliminate, because it's impossible for things to just cancel out if they're both positive. So is there a minus sign? Yes. Are both terms perfect squares? What's the square root of each term? 2m and 7. So it means you're going to have two parentheses of the exact same thing, but one has a plus sign, one has a minus sign. Okay. What about the next one? Is there a minus sign in between the two?
Yeah.
All right, check that box. Are they both perfect squares?
Yeah. The GCF.
There's a GCF. What are they both divisible by? So divide by 2, that makes it x squared minus 25. Are those perfect squares?
Yeah.
Then that means we've got x and 5. In both parentheses, one was a plus, one was a minus. What also needs to be included for your answer? The GCF, the 2 and the 5. Yes. Good question. Okay. So flip to the next page. Look at number 10. Problem number 10. Is there a minus sign in the middle?
Yeah.
Yes. Are they both perfect squares?
Yeah.
What's the square root of 225? 15. That means you have m plus 15, m minus 15. Again, you could still factor this like normal, but why it is now helpful, look at number 14. Number 14, is there a minus sign in the middle? Yes. Before today, your step for number 14, you would factor, and you would have 81b squared and negative 16, but then have to multiply 81 times 16. And find the numbers that multiply to give you that, but then we'll add up to 0. Right? So that does not sound great. Instead, the trick that we were talking about, is there a minus sign in between? Yes. Are both those terms perfect squares? What's the square root of each of them? 9 times c and 4. So you write the parentheses twice. One gets the plus, one gets the minus. Again, that is called a difference of squares. Difference is the one to help you remember that it's a negative sign. Or it's a minus sign between. So if you look at number 9, what is it? It's prime. Why? If there's a plus sign in between, it's in algebra 1 not possible to go further. Yes. Okay. And then something, if you ever know, do y'all ever just like look at your formula chart to look at things?
No.
Some people do. I want y'all to just be aware of it. Your formula chart has, it's written as a squared plus 2ab plus b squared equals a plus b squared. It's also written as a squared minus 2ab plus b squared equals a minus b squared. This is the mathematical representation of your perfect square trinomials. Now, I remember when I was in Algebra 1 and I was showing those two things, I thought, doesn't make sense. No idea what they're talking about. Totally fine. Because this is the mathematical representation of what we first did. Where it was, you get the first one, look at the last one, is the middle term double of when you multiply them together. What I think this is helpful for is when you're trying to think about the perfect square trinomial, it has the 2 in there. Like, it just helps me remember, like, when I was learning it for the first time, I thought it all looked nuts, but I could at least see the 2. That made more sense to me. And what also made a little bit more sense, or makes a little bit more sense, is you can see the sign matching. So, it's on your formula chart. I just want y'all to see that, like, it exists. Whether or not it's very helpful to you is something different. Something that is also on your formula chart is it has the a squared minus b squared equals a this. Which is what we were just doing for our different squares. Okay. So I just want y'all to know that it's on your formula chart. This one I think is a little bit more like understandable, at least in my eyes, of like, oh, it has the two things squared, the plus minus thing. Number 12, is that the question? Okay. What do you do first for number 12? Divide everything by 2? And that means it's m squared minus 9m plus 8, right? Are the first and the last terms perfect squares? Okay, then go back to factoring. Is it factorable? This would be considered the easy factoring problem because there's nothing in front of the m squared. -8. Are there numbers that multiply to give you -8 but add up to -9? Or sorry, they multiply to give you +8 but add up to -9.
-8
and -1. What was our GCF?
2.
So it's not that it was one of our special cases for that problem, but it was still factorable. That just went back to factoring multiple. Okay. On your notebook paper, I want you to write these down. We're going to go through a few examples together, so maybe you can just write these down. Look at the first term, look at the last term. Are they both perfect squares?
Yeah.
What's the square of the first one? 5x. What's the square of the last one? 6y. When you multiply those together, that's 30, but then double it, because it'd be in each of those two boxes when we factor. Is that equal to the middle term?
Yes.
Yes. Then take whatever that is, so plus sign, which means squared on the outside of the parentheses, you're done. You're thinking of the different difference of squares. This one would be considered the perfect square trinomial, which means it's the same parentheses twice. So if you look at the next one, trinomial, so it's either the shortcut of the first and the last term, or it's neither of those, and we have to factor like normal. Are those both perfect squares?
No.
What's the square root of each one? X and 5. When you multiply those together and double it, does that give you the middle term? Okay. So that means it's not even the perfect square trinomial, it's neither. So we either factor it like normal or it's prime. Factoring like normal. Again, easy factoring problem because there's nothing in front of the x squared. Look at the 25. What numbers multiply to give you 25 but add up to -5?
Oh, nothing.
Well, what numbers multiply to give you 25? 5 and 5 and the 20. Sorry. Wait, 25 and 1. Okay, so 5 and 5 and then 25 and 1. And you know it's going to give you 5. So what does that mean for this? Okay. Go ahead and write these two down on your paper now. I'll give you a minute or two to write it down. Check. Are those both perfect squares? Before you do that, though, there is a minus sign, so that part's good. That's the thing. Always check for first. We'll see the negative sign. But what's the number one, like first thing you should always do is factoring GCF if possible. That is always what I still want you to do first. So if we look at that first problem, what's the GCF of 144 and 16? They're both divisible by 16. Y'all have calculator desks. What's 144 divided by 16?
9.
9. So this is 9a squared minus 16 divided by 16 is 1. So b to the power 4. Are those two terms still perfect squares? Yeah. If they started like that and you take out the GCF, it's still going to stay that. So 16 is in front, because that was our GCF. We have our two parentheses. One has the plus sign, one has the minus sign. What's the square root of each of those two terms? 3a and b squared. So 3a and b squared. Okay. Now refresher of solving with square root. What happened last class? There is one more, so if you want to write down that final problem that I just showed on the board, you're welcome to do so. Okay, so on this left side, it's just parentheses squared, which means you can square root each side. What that does on the left is just take away the squared, which means the parentheses are now gone. You're left with w minus I.
3.
3. On the right side, it's 15 a perfect square. Okay, so you keep it as a radical. Can you simplify the square root of 15? Because what numbers multiply to give you 15? 5 and 3. No pairs out of that. So it's still the square root of 15, but not just the square root of 15. It's the positive and negative plus or minus the square root of 15. Okay. Now, since there's still a square root in the problem, that means you're not going to give me like a normal answer like 2. Like that's not going to be your answer for this problem. It's going to look similar to how our answers for quadratic formula look when you couldn't simplify a radical. Your answer is still going to have that symbol in there. How would you get w by itself though? Add the 3 to the other side. Now something that I mentioned, you usually just want to have the radical part go second and just like normal regular whole number answers, numbers out of a radical first, so it would be a positive 3 plus or minus the square root of 15. This is actually showing two answers. One answer would be 3 plus the square root of 15, the other is 3 minus the square root of 15. So if my directions say write your answer as a decimal, in your calculator, you would do 3 plus the square root of 15, 3 minus the square root of 15. But most times it's going to just say write it as a simplified radical. Okay. That was one of the versions from last class. Next version, if there are things around the parentheses first. You can't just square root this next one. Not yet, at least. What do you have to do first?
Add 5.
Okay, so it's getting the parentheses by itself. So add 5. You'd be left with 3, and then y minus 2 squared equals 27. What's still around the parentheses that you need to get rid of? 3. The 3, how do you get rid of that? Divide by 3. So y minus 2 squared equals 9. Do you now have parentheses by itself?
Yeah.
Okay. That means you are now getting the square root. What that does is takes away the squared, which means the parentheses are gone. Y minus 2 equals positive and a negative 3. Again, what you were looking at. Now, this, you got the square root of something. That means there are two, like, regular looking answers. Answers we're used to seeing. Take this, it goes into two equations. Y minus 2 equals a positive 3. Y minus 2 equals negative 3. What are the two answers to that problem?
5 and negative 1.
5